In today's notes, we're going to talk about the tangent function. Since the tangent of x is equal to sine over cosine, the tangent function is undefined when cosine of x is equal to 0. Remember, you can never divide by 0, so if cosine is 0, that means we have 0 in the denominator, which can't happen. Therefore, the tangent function has vertical asymptotes whenever the cosine of x is equal to 0. So if you take a look at the picture down here, here's my cosine of x graph in this kind of light gray, and you can see whenever the cosine is 0, the tangent function has an asymptote. Similarly, the tangent and sine functions each have zeros at integer multiples of pi because the tangent of x is equal to 0 when sine is 0. So if you think about it, if sine is 0, which is on the top of our fraction, 0 divided by anything is going to be 0. So if we take a look, here's my sine function over here in this light gray, and whenever the sine function is 0, so is the tangent function. If we look below, we can talk about some different properties of our tangent function. Here's our graph of our tangent function without the sine or cosine with it. We've got our asymptotes and then our graphs, which are going to repeat as we go through, and it's going to go on forever. So these shapes are going to continue as we move to the right and to the left. So our domain of our function, we are using up almost every x value except for the ones where we have these asymptotes. So our domain, we can say that x cannot equal pi over 2 plus n times pi, where n is an integer. So basically, here's pi over 2. That's where we cannot have an x value, and it's every pi over 2. So if we add pi to it, we're going to get to all the other ones that don't exist. So the domain can be anything except for those numbers. If we take a look at our range, our y values, we're headed with this, we can look at just one piece of this, is going down forever and up forever. There's nothing in between that we can't use. So our range is going to go from negative infinity to positive infinity. We're using everything for our range. My y-intercept is at 0, 0. My x-intercepts are happening where it's crossing over the x-axis, and that is at n times pi, where again n is any integer. And then our asymptotes are happening right here, again at that pi over 2, and then every pi after that. So it's going to be very similar to our domain. So our asymptotes, x is equal to pi over 2 plus n times pi, where n is an integer. Underneath that, it says the general form of our tangent function is going to be very similar to our sine and our cosine functions, where we have that a value, the b, the c, and the d, and the a, b, c, and d will affect the tangent function the exact same way it affected the sine function. If we take a look at the period of our tangent function, the period of a tangent function is the distance between any two consecutive vertical asymptotes. Two consecutive vertical asymptotes used most often are these first two, which is negative pi over 2. So x equals negative pi over 2, and x equals pi over 2. And the distance between negative pi over 2 and positive pi over 2 is a length of pi. So our period, it's going to be similar to that of our sine and our cosine, but we're taking pi and dividing it by b instead of taking 2 pi and dividing it by b. So the period of the tangent function is shorter than the period of the sine and the cosine function. But this right here, pi divided by b, is how we will find the period of our tangent function. If you have questions about this, let me know. Otherwise, you can get on to example 2 to start graphing.